Hi friends, let us do some important limit problems. All these problems, these are based on our very important result, limit theta tends to 0 sine theta by theta, right, which we have proved already that it is 1, right. We have to convert this, we have to simplify this to get into some sine theta by theta kind of format. Okay, earlier we discussed limit theta tends to 0 sine theta by theta, this is equal to 1. We have derived the proof also, we have shown this graphically also. This function, as long as theta is in radians, this function, though we don't define it at theta equal to 0, this approaches 1 from both the sides, right? This is an even function because both are odd functions, sine theta and theta, and it is symmetric about y-axis. So, and this function approaches 1, so the limit is actually equal to 1. Okay, another important result. Let's say limit h tends to 0, cos h minus 1 by h. Okay, we can write it as cos h minus 1 as minus 2 sine square h by 2. We know this, right? Cos a plus b. How do we do this? Cos a plus b is cos a cos b minus cos a cos b minus sin a sin b. Right? So, and if a is equal, a and b are equal, what does that mean? Cos 2a equals cos square a minus sin square a. Right? If you have to convert this, cos square, you can write it as 1 minus sin square. This becomes 1 minus 2 sin square a. Okay. Obviously, cos 2a is 1 minus 2 sin square a. Right. And cos 2a minus 1, cos 2a minus 1 is equal to obviously minus sin square a. Okay. Instead of 2a, we are putting h here. So cos h minus 1 will be obviously minus 2 sin square h by 2. Here 2a by 2 is a. Here h by 2 is this h by 2. Right. Now, now we converted this into the sine format. Right. Sin square h by 2. Now let's assume h by 2 is some theta. Okay. If h is tending to theta is h by 2. Obviously, if h is tending towards 0, theta will also also tend towards 0. So theta tends to 0, and we can write it as sine theta by h into sine theta. Okay. So now we know the limit of this thing. Limit theta tends to 0 sine theta. So limit of some product is equal to product of limits. So limit of this into limit of sine theta. So limit of this is 1, limit of sine theta is 0. So this is equal to 0. Basically, this is another important result. Limit h tends to 0, cos h minus 1 by h is actually equal to 0. Like this is equal to 1, this equal to 0. This is an important result. Okay. Let us do some problems based on this. Okay, we wanted to do these problems. We'll do these problems, but even before doing this, let's attempt some even basic problems and then we'll come to this. Right. For example, limit sine root 2 theta by root 2 theta. Right. So both are same. Please note, and if theta is tending to 0, obviously root 2 theta will also tend towards 0, tends to 0. Right. So root 2 theta, we'll call it x. If we call it, then this is limit x tends to 0 sin x by x, which is equal to 1. This is in our very familiar format. Limit theta tends to 0 sin theta by theta equal to 1. Now we are given like this, sin kt by t. Right. So we want this and this part and this part to be same. What we do? We'll multiply with k here and k here. Nothing changes, right? So that is k sin kt by kt, and this k will bring it outside. It doesn't matter, right? Limit of product is product of limits. Right. So what does that mean? And kt, if we call it as theta, if t is tending to 0, kt will also tend to 0. This becomes sin theta by theta. So k into sin theta, limit theta tends to 0, sin theta by theta. This is equal to k. Similarly, sin 3y by 4y. What we will do? We'll multiply. We want 3y here. We want in the denominator 3y. Because changing something within sign is difficult. So what we'll rather do? We'll change this denominator. So what we'll do? We'll multiply with 3, both numerator and denominator, and bring this 4 outside. Okay, we are bringing this 4 outside. Then 3 sin 3y by 3y. Obviously, if y is tending towards 0, 3y will also tend to 0. Right. So then limit 3 sin 3 by 3 by 3y by 3y, this is equal to 1. So this becomes 3 by 4. Okay. So we are replacing 3y with theta. Right. If y tends to 0, 3y also tends to 0. That means theta tends to 0. Okay. Very basic problems. Direct substitution of sine theta by theta format. Let us look at few more. In this case, h by sine 3h. Okay. So here also we'll multiply with 3, both numerator and denominator. Then we will get this and we'll take inverse of this. 1 by 3 into 3h by sine 3h. What does that mean? 1 by sine 3h by 3h. We can write this like this, right? Right. It is h tends to 0 minus 0 plus. It doesn't matter much here. Okay. So now uh, limit of a by b is limit a by limit b. That we know, right? This product rule, quotient rule, product sum rule, difference rule. Limit applies to both the function. Limit of x by g of x is limit of f of x by limit of g of x, right? So now again 3h by 3h and 3h is tending towards 0. So this is equal to 1. So 1 by 3 into 1, this is 1 by 3. Again, tan 2x, we can write it as sin 2x by cos x, cos 2x. Cos 2x, we are not much worried because cos 0 is anyway 1. So sin 2x by cos x into cos 2x. So we'll multiply by 2 on both sides. We'll get 1 by cos 2x. Anyway, we are not worried because cos 2x is anyway 0. This is anyway 1. And we get 2 sin 2x by 2x. Basically, this part. This part. We are getting. So we want whatever is there within sin 2x, same thing to be in denominator. And if x is tending towards 0, obviously 2x will also tend towards 0. So this part will be equal to 1. So basically 1 into 2, this is equal to 2. Similarly, 2t by tan t. We will convert to sin and cos. Sin t by cos t. Cos t we are not much worried. Okay, cos t will go to the top. Cos t because cos 0 we know it. And sin t, t by sin t, we can write it as 1 by sin t by t. Okay, so limit we will take inside. Limit t tends to 0 cos t. This is anyway 1. And sin t by t, t tends to 0. This is also 1. And we have 2 outside. So this limit is equal to 2. Very simple algebraic or trigonometric manipulation to get in the form of sin theta by theta when theta tends to 0. We are trying to get this in this format. Let's look at this. X into cosecant 2x by cos 5x. Right, let us convert this into again sine. Cosecant 2x is 1 by sin 2x, right? X by sin 2x and cos 5x. Cos 5x we are not so worried because cos 0 is anyway 1. So this becomes 2x by sin 2x. We can write it as 1 by sin 2x by 2x. It doesn't matter. So this part the limit is 1, basically half into 1 into again 5x it is 0, 1 by cos 0 it is equal to 1. So the answer is 1 by 2. In this case 6x squared cot x cosecant 2x. Let us again convert everything into sine and cos. 6x squared cos x by sin x cot x, that is cosecant 2x is sin 2x. Right. Sin 2x, we have an x square here and we have sin x and we have sin 2x. Right. So let us use this. X square we will write it as this 6x square, right? We'll write it as 3 into 2 x into x. Okay. This x, and this 3. That is 3 to 6, 6x square. We'll break it like this. Right. Why we are breaking this? Because we want sin x by x and we want sin 2x by 2x. Okay, we'll break it like this. Cos x we are not so much concerned. So what is the limit? Basically 3 into 1 into 1 into 1. This is equal to 3. Right. This is anyway 1. This is also 1 because we can write it as 1 by sin x by x. This we can write it as 1 by sin 2x by 2x. X tends to 0, which automatically means 2x also tends to 0. Okay, let's take this one now. This one, x plus x cos x by sin x cos x. Let us break this. X by sin x cos x plus x cos x by cos x. So this and this will get cancelled. And x by sin x. We'll take this. X by sin x, this limit tends to 1. And cos 0 is anyway 1. So this becomes, this is 1 and this is 1 and this is 1. Basically 1 into 1 plus 1, which is equal to 2. Right. So x by sin x, we can write it as 1 by sin x by x. That's what we have done. We have written limit of product is equal to product of limits. Right. Limit of this and this is equal to product of first this limit and this limit. Okay. Limit of sums is equal to sum of limits also. Right. Now here, x square minus x plus sin x by 2x. Let us expand this also. X square by 2x, which is x by 2, minus x by 2x minus half plus 1 by 2 sin x by x. Sin x by x is the form that we want. This is equal to 1. When x tends to 0, this is 0 minus half plus half into 1. So minus half plus half, which is equal to 0. Very simple. We are getting everything in the form of sin x by x. Okay. In this case, 1 minus cos theta by sin 2 theta. So we don't have any theta here. Okay, we have to manufacture something here. What we'll do, 1 minus cos theta, we'll write it as 1 plus cos theta into, we'll multiply this 1 plus cos theta by 1 plus cos theta. Cos theta are not so much worried because cos theta is always 1. Why we are doing this? Because you want 1 minus cos square, which is equal to sin square theta. Right, this is equal to what? This is equal to sin square theta. And so that we want to cancel this sin 2 theta, we can write it as 2 sin theta cos theta. Right, we don't want to eliminate this some 0 in the denominator. Right, the numerator 1 minus cos theta, numerator is also 0, but we want to take care of the sin 2 theta. So now we'll write it as numerator is sin square theta and denominator is 2 sin theta cos theta. This sin theta and this square will get cancelled. We will left with sin theta by 2 cos theta into 1 plus cos theta. Now we can substitute. Right. So this cos 0 is anyway 1. This numerator denominator becomes 2 into 1 plus 1, which is 2 into 2. Numerator is anyway 0. So the answer is 0. Right. Everywhere we are using this sin theta by theta format. We are trying to get in the sin theta by theta format, or we are trying to simplify these trigonometric expressions to eliminate zeros from the denominator. Okay, x minus x cos x by sin square 3x. Okay, we'll write it as x into 1 minus cos x by sin square 3x. Right. Now, there is a square here. We want 2 x's. Okay, sin square 3x, we can write it as sin square. Let's say what we'll do. So, we want 3x whole square. Right. So, what we'll do? So, we'll divide with 9x square, both numerator and denominator. So, this part will become 1 now. Limit of this part will become 1. So this becomes limit x tends to 0. Right. This x and this x will get cancelled. We'll be left with in the numerator 1 minus cos x by 9x. That is nothing but 1 by 9 into limit of 1 minus cos x by x, and in this denominator 3x by x whole square. Okay. So limit of power, we can take the limit inside also. Anyway, if x tends to 0, 3x also will tend to 0. This denominator will become equal to 1. Okay, denominator is equal to 1. Now 1 minus cos x by x. In the very beginning, we already proved this. Right. 1 minus cos x by x, or cos x minus 1 by x. Right. We are already proved that in the beginning. Now here we are getting the same thing. 1 minus cos x by x. It is equal to 0. So the numerator is 0, denominator is 1. So net it is 0. 1 by 9 into 0 by 1. This is equal to 0. Now here sine of 1 minus cos t by 1 minus cos t. See here there is no direct theta, but still it doesn't matter. Why? As long as 1 minus cos t, if this is tending to 0, we can write it as sine theta. We can write this in the form of sine theta by theta. Right. When t is tending 0, then cos t will be tending towards 1. 1 minus cos t will be tending towards 0. So this we can replace with some theta. Okay. 1 minus cos theta is cos t is some theta. So sin theta by theta, this is also equal to 1. Similarly, see here another good thing. Sin of sin h by sin h. Again, if h is tending to 0, obviously sin h will also tend to 0. So this is in the form of sin theta by theta. Right. What is theta? Theta is sin h. So this limit is also equal to 1. Okay. Again, limit theta tends to 0, sin theta by cot 2 theta. So we have a cot 2 theta and we have sin theta. But the problem is cot 2 theta is cos 2 theta by sin 2 theta. Right. There is a denominator in the 0. That's why we cannot directly substitute theta. So what we will do, we will write it as cos 2 theta by sin 2 theta. And what is sin 2 theta? It is 2 sin theta cos theta. Right. So we will cancel this. We will be left with what? Cos 2 theta by cos theta. Theta we can directly substitute. Right. This is equal to 1. This is 2 into 1. So which is equal to half. Right. We are direct. plain simplification here. Right, plain simplification to eliminate this sine theta from the denominator. Okay, sine the cot 2 theta, we got a sine 2 theta, and then we have sine theta in the numerator. That's why we expand it as 2 sine theta cos theta. Now tan 3x by sine 8x. Tan 3x is sine 3x by cos 3x by 1 minus sine 8x. We have the sine 3x in the denominator. We have sine 8x in the numerator. We have sine 8x in the denominator. What we'll do, we'll multiply we'll take two x's, one in numerator, one in denominator, this x and this x. And in the denominator, what we want? We want 3. In the denominator, we want a 3x. So let's say that's why we'll multiply with 3 and 3 again. In the numerator, we want 8 because there is an 8x in the denominator. We want 8 by 8. So 8, 8. Okay. Basically, this entire part is equal to 1. Okay, we multiplied this expression by 1, but in this format. Why? Because we want to capture this one and this one and this one together. Okay. 1 by cos 3x, we are not so much worried. So 1 by cos 3x, then sin 3x by 3x, and 8x by sin 8x, right, into 3 by 8. This 3 by 8, we have got it outside. Okay. So this part is equal to 1. This is 1 and this is 1. So 3 by 8 into 3 ones, which is equal to 1. Right. We are trying to modify this everything to get in the form of sin 3x by 3x. Here, sin 3y cot 5y, y cot 4y. Okay, let us again simplify this. Cot 5y is what? Cos by sin 5y. And cot 4y is also cos by sin 4y. Okay, we have sin y. We have a sin y by 3y here. So we have to get a 3 here in the denominator. And at the same time, we have sin here, we have sin here. Basically, we want y and y in numerator and denominator. So what we will do? We want first y and y in the numerator, right? At the same time, we want 3 and 3 in the denominator. We want 3 and 3 together, and we want 4 and 4 together, and we want 5 and 5 together. So basically, this part is equal to 1, but just for to get in sin theta by theta format, we are doing this, right? Now, what is this? What is this? Sin 3y by 3y, then sin 4y by cos 4y, and cos 5y by sin 5y into this one. What is this one? One is sin 3 into 4 into 5y by 3 into 4 into 5y. This is basically 1. And why we are doing this? Because we want sin 3y by 3y. Okay, 1 3 is gone. We'll take this one. This will take this 1 3. Then we want sin 4y by 4y. Right. So sin 4y, we'll take this. We'll take this 4 and we'll take this 5. That is this. We want sin 5y in the denominator by 5y. We'll take this. We'll take these two. Okay, we'll take this. That is this one. Then we want cos 5y. This we'll take. That is here. Cos 4y. That is here. Then what is left? 3 into 4 into 5. These 3 are left. That is this. Okay. Now sin 3y by 3y. When y tends to 0, obviously 3y also tends to 0. This is 1. 4y by 4y. This also, when y tends to 0, 4y tends to 0. That is also 1. This is also 1. This is anyway 0. Cos 0 by cos 0. This is anyway 1. We are left with 3 into 4 by 5 and all ones. Right. That is 12 by 5. Next one. Tan theta by theta square cot 3 theta. What is tan theta? Sin by cos. And cot is what? Cos by sin. Cos 3 theta by sin 3 theta. Okay. Which is nothing but if you take this to the numerator, sin theta into sin 3 theta by cos theta into cos 3 theta. We are not so concerned about cos theta and cos 3 theta. And we already have 2 thetas. 2 thetas, what we are just concerned, there should be a 3 in the denominator. That's why we multiply with 3, both numerator and denominator. This cos theta and cos theta as is. Then we'll multiply with 3, both numerator and denominator. And this becomes 1, 1, and 3. Right? Theta tends to 0, cos theta, this is also 1, this is also 1. So 3 by 3, 3 by 1, this is equal to 1. So total is 3. Right? Next, theta tends to 0. Theta cot 4 theta sin square theta by cot square 2 theta. See, denominator there is a 0, numerator also there is a 0. Even in the previous class also, there is a 0 in the denominator, there is a 0 in the numerator. That's why we are trying to get everything in sin theta by theta format. Otherwise, we can directly substitute. Okay, here also we cannot directly substitute. What we will do, let's simplify this. Cos by cos, cos by sine, which is cos 4 theta by sine 4 theta. Again, cot square is what? Cos square 2 theta by sine square 2 theta. Let's take this to the numerator. We'll get theta cos 4 theta into sine square 2 theta by sine square theta into sine 4 theta into cos square 2 theta. Right? This simplifies to this. Right? Now, what is sine 2 theta? Sine 2 theta, we can write it as 2 sine theta cos theta whole square. Because we want to eliminate the sine square theta. Right? Sine 2 theta, we can write it as 2 sine theta cos theta whole square, which is this square. Right? Now there is a sine square here. There is a sine square here. These two will get cancelled. Right? Sine square, this also 2 sine theta cos theta whole square is, there is some sine square here. This sine and this sine will get cancelled. What will be left with? There is a 2 square that is equal to 4, and there is a theta, there is this theta, then cos 4 theta, and there's a cos square theta, there's a cos square theta. In the denominator, what we have? Cos square 2 theta and sine 4 theta. So this is fine. We have 4 theta here, we have sine 4 theta here, rest all are cos. So it doesn't matter much. So 4 theta by sine 4 theta and cos 4 theta, cos square 2 theta. So this all is 1, and this is also equal to, this also equal to 1, right? So net this is equal to 1. Right guys? These are all very simple basic problems based on this result. Limit theta tends to 0, sine theta by theta. Right? Very important result. And we can extend this to limit h tends to 0, cos h by minus 1 by h. This result will be equal to 0. This result is equal to 1. And we have covered whatever we have wanted to cover also. These are problems also we have covered in this list of exercises. Right, guys? Hope you like this. All these problems, whenever we are getting in 0 by 0 format, we can take the help of this result, sine theta by theta, or this result, to simplify and get to some limit. Right, guys? Hope you like this. Thank you.